இதுல இந்த fluids பத்தி பார்த்துட்டு இருக்கோம். அதுல சில கணக்குகள். Welcome to Bharat. Thank you very much. Kindly attend. We are seeing some problem in the portion fluids. Just some fluids, some problems. Then we are moving to, this is the portion which I am going to discuss with you today. This is, you see, காந்தவியல் மற்றும் மின்காந்தவியல், அதாவது magnetism and electromagnetism. இதுல what we are going to deal today is காந்தப்புலம், அதாவது magnetic field, காந்தவிசை கோடுகள், magnetic field lines, and also காந்தப்பாயம், magnetic flux. These are the things we are going to discuss today. First we will see some 2-3 problems which we have worked out in the portion called fluids. So we will first see the problems. Just I will screen share. This is the first problem which I am going to work out. A man whose mass is 90 kilograms stands on his feet on a floor. The total area of contact of his 2 feet with the floor is 0.036. Take G, acceleration due to gravity. Actually 9.8 they used to tell earlier, 9.8 meter per second, second square. Now they have approximated it to 10 meters per second square. How much is the pressure exerted by him on the floor? This is Tamil medium. This is, sorry, English medium and Tamil medium also. I will read it out. See, 90 கிலோ நிறையை கொண்ட மனிதன் ஒருவன் தண்ணீர் கால்களிலும் தரையில் நிற்கிறான். தரையுடன் கால்களின் பரப்பளவு, அதாவது area of the foot is 0.036 meter square. G is equal to 10 meters per வினாடி ஸ்கொயர். அவன் உடல் எவ்வளவு அழுத்தத்தை தரையில் ஏற்படுத்துகிறது அப்படிங்கறத இப்ப நம்ம பார்ப்போம். சரியா? Just will write down all the datas. I'll just write down all the datas. I'll write down the datas first. First is his weight. Weight or mass. First I will write down his weight, then we will calculate the force. Weight is equal to 90 kg. Weight is equal to 90 kg. So this is called as உந்து விசை, அதாவது upward force சொல்றோம் இல்லையா, அதுதான் இது. Just is உந்து விசை, or it's called the thrust, THRUS. This is the thrust. These are all the data given, and G is equal to 10 meters per vinadi square. சரியா? Meters per second square or meter per vinadi square. And area of the foot is equal to 0.036 meter square. 0.036 meter square. Okay. See, formula. What is the formula? P is equal to F by A. Don't forget that formula. That I will write here. P is equal to F by A. Okay. So F is equal to what? F is equal to M into G. Small m into G. Okay. F is equal to M into G. M into G. So 90 into 10. 90 into 90 kilogram into 10. 90 into 10, that is equal to 9,000. சரியா? Okay. 900 newtons. 900 newtons. So force is expressed in newtons. Unit of force is newtons. 900 newtons. So if P is equal to F by E. What is the area? Area is 0.036 meter square. So again I write the formula. P is equal to F by A. So here F is equal to 900 newtons divided by 900 newtons divided by 0.036. That is equal to how much? 8,500 pascals. Why we are telling it as pascals? Because this is in newtons. This is per meter square. Newtons per meter square is called pascal. This is the unit for pressure. Okay. This is the sum which I wanted to tell you. You please refer back your 8th standard textbook also. In the same chapter, fluids, you will have a one elephant sum. That is a very interesting sum. Same sum, same type of way you can do that. There you can find the weight of the elephant, and there they will ask weight exerted by 1 foot of the elephant. Okay, that's a very interesting sum. That also you try to do it. That is given in your same principle, same, no, nothing is changed in that. So that also you try to work out as a practice. Okay, this is the first sum. What are the data is given? I have written. So P is equal to F by A is a formula. So 900 divided by 0.036 is equal to 8,500 pascals. Okay, this is the first sum which we have worked out. Now we will go to the second sum. This is the portion. Then we'll go to the second sum. This is in Tamil medium. I'll just read it out in English medium also. So we have seen this formula. P is equal to rho Hg. So now you see 0.85 meter திரவத்தம்ப உயரமுள்ள நீர் அடர்த்தி. It is rho W is equal to 1000 kilogram per meter cube. மற்றும் அதே உயரமுள்ள மண்ணெண்ணெய் அடர்த்தி rho K is equal to 800 kilogram per meter cube. ஆகியவை செலுத்தும் அழுத்தத்தினை கணக்கிடுக. What is the pressure exerted by the liquid column? The liquid column, the formula we have worked out. P is equal to H rho G. This is the Tamil version. English version also I will just show it you. You just see. Calculate the pressure exerted by a column of water of height 0.85 meters. Density of water is rho W is 1000 kilogram per meter cube, and kerosene of the same height, density of kerosene rho K is equal to 800 kilogram per meter cube. So the same formula we have to apply. P is equal to H rho G. How you should calculate? I'll just write it down. Here, once again, I write the formula. P is equal to H rho G. This is the formula. What are all the data given? Height H they have given. Height of the liquid column is, this is constant for both 0.85 meters. 0.85 meters. Rho W as the density of water. Rho W is equal to 1000 kg per meter cube. 1000 kg per meter cube. Okay, this is the density of water. This is the density of water. Density of water. நீரின் அடர்த்தி. நீரின் அடர்த்தி. Okay, இப்போ what we have to calculate? The pressure due to water column. The pressure due to water column. திரவத்தம்பத்தினால் ஏற்படும் அழுத்தம். Pressure due to water column. Due to water column. நீரினால் ஏற்படும் அழுத்தம். நீரினால் ஏற்படும் அழுத்தம். So what is the formula? P is equal to H. Here the density of water is there, no? So you can develop as H rho W into G. That is equal to what? 0.85 into 1000. 1000 is the density of water. 1000 into G. G is equal to what? Acceleration due to gravity. This is a constant. Earlier they used to tell 9.8 meters per second square. Now they have approximated it to 10. Okay, By multiplying all these, you will get the answer of 6,800 pascals. 6,800 pascals. Okay, by multiplying all this, you will get 6,800 pascals. Okay, this is the answer. Okay, please go through. Sorry. This is not 6,800 pascals. Sorry. This is 8,500. Sorry, 8,500 pascals. 8,500 pascals. Okay, this is the answer. Just 0.85 into 10,000. Then the answer is 8,500 pascals. That is the pressure due to the water column. Now, the pressure due to the kerosene column also we can find. So here also the data are the same. The formula is the same. Only thing is height is the same. Because height of the liquid column, both the things are 0.85 meters only. Okay. Now you see it is 0.85 meters of the height. Then rho k is equal to 800 kg per meter cube. So this is the same. Now G is equal to 10 meters per second square, meters per vinadi square, or 10 meters per second square, 10 meters per second square. Okay, this is the three data are given. Now P is equal to H rho k into G, that is equal to 0.85 is the same into 800 into 10. 0.85 into 800 into 10, that is equal to 6,800 pascals. 6,800 pascals. This is how you have to calculate the pressure exerted by a liquid column. Okay, these are all very simple sums. Something that they may ask, even they will give the pressure they will give. Sometimes they may ask to calculate the density, or like that. It can be interchanged. Anything can be interchanged. Okay, like this is the basics of this sum. Okay, next another sum also we will just calculate. Next, if you see, you have a block of mystery material of 12 centimeters long, 11 centimeters wide, and 3.5 centimeter thick. Its mass is 11,155 grams. What is its density? Will it float in a tank of water or zinc or sink? This is the problem. Whether this type of problem only they will ask in all your service commission exams. So now we can work it out. We can work it out. Now I'll tell the Tamil version also. Then we will work it out. Yes, 12 சென்டிமீட்டர் நீளமும் 11 சென்டிமீட்டர் அகலமும் உள்ள அகலமும் 3.5 சென்டிமீட்டர் தடிமனும் கொண்ட ஒரு வினோதமான பொருள் உன்னிடம் உள்ளது. அதன் நிறை 155 கிராம் எனில் அதன் அடர்த்தியாது தண்ணீரில் அது மிதக்குமா அல்லது முழுகுமா? சரியா? ரைட். Now we will work out this. So what are all the things they have given? Length, breadth, and height. All the things they have given. Length is equal to 12. Breadth, B, is equal to how much they have given? 11. H is equal to 3 point. Length, breadth, height, everything they have given. The formula for volume is LBH. Okay, it's LBH. So mass is also they have. Mass is equal to 1155. So what is the formula I told? D is equal to M divided by V. Okay, V. So this V we have to find out. Volume is this volume we have to find out means we have to just multiply all the three. LBH is the formula. V is equal to LBH is the formula for this. So what we have to do is D is equal to M by V. 1155 divided by 462. Divided by 462. That is equal to 2.5. It is equal to 2.5 gram per centimeter square. 5 gram per centimeter square. Okay. Now, if it is 2.5 means it is above the volume of water, above the density of water. So this object will not float. Will not float because its density is more than water. Water density is 1. Density of water is dW is 1. So it is more than 1. So anything is more than 1, it will get sink in the liquid. Okay, this is the sum which I wanted to tell you. Kindly go through this, and these are all very interesting sums. Some more sums also. When next class I will put it also in your exercise part sums also. I'll just try to work it out in my next class. Okay, next. Next lesson, what we are going to see is about magnetism. See, I just given it to you. I just shown to you Gandhaviyal, Mingandhaviyal, magnetism, and electromagnetism. Okay, first we'll just start with the small experiment. Okay, now you find lot of pins here. Nariya pinning port. What I am going to do is I am just going to bring a magnet nearer to it. I'm bringing the magnet nearer to it. If you see at one stage, all the majority of the pins got stick into the magnet. You see, majority of the pins is getting stick into the magnet. This is happening why? Once again, I will show it to you. I'm just putting the pins here. Pins are gem clips. Whatever you want, you can use it. If you have a magnet, just do it in your house. Just you see, I am just bringing nearer to the, and almost all the things got stuck into the magnet. Okay, this is why this is happening. We are going to see why this is happening. Okay, right. You just remember this experiment. I am just telling you what is exactly it is happening. What is exactly the definition for this? First, magnetism, Gandhaviyal மற்றும் மின்காந்தவியல், magnetism and electromagnetism. Okay, first we are going to see what is magnetic field. What காந்த புலம்னா என்ன அப்படிங்கறத நம்ம பார்ப்போம். இப்ப just you see, காந்தத்தை மேஜை மேல வச்சு some pins are and the gem clips we have put near to it. காந்தத்தை மெதுவா அதை நோக்கி நகர்த்தும் பொழுது அனைத்தும் காந்தத்துடன் முட்டிக்கும். We have seen majority, almost all the pins got stick into the magnet. Put a magnet on the table and place some gem clips or pins nearby. If you push the magnet towards the clip, at one point majority of the at one point all clips jump and get stick into the magnet. This is happening why? What is the phenomena behind? Okay, next. What we are telling, இதுல என்ன தெரியுது? காந்தங்கள் அவற்றை சுற்றி கண்ணுக்கு புலப்படாத காந்த புலத்தை கொண்டுள்ளது. I am first telling in Tamil, then I will explain it in English also. காந்த புலத்தை சுற்றியுள்ள காந்தத்தன்மையை உணரக்கூடிய இடம் காந்த புலம். From this activity, we notice that the magnets have invisible field all around them, or this is called magnetic field. And the magnetic field is the region around the magnet where its magnetic influence is felt. Okay, this is the most important. Magnetic field is the region around the magnet where its magnetic influence is felt. எங்க வச்சா அது அந்த பின்ஸ் இருக்கு இல்லையா, அது எல்லாம் இதுல ஒட்டிக்குதோ அதுதான் அதனுடைய magnetic field. See, the magnetic field is the region around the magnet where its magnetic influence is felt. இதுதான் வந்து magnetic field ஓட definition. So அது ஒரு ரேடியஸ், எத்தனை வகையில இருக்கு, எவ்வளவு வரையில் அந்த அந்த எவ்வளவு தூரம் வரையில் அந்த மேக்னெட்டுடைய இன்ஃப்ளூயன்ஸ், மேக்னெட் பவர்னு சொல்றோம் இல்லையா, மேக்னெட் எவ்வளவு தூரம் பவர்ஃபுல்லா இருக்கு, எவ்வளவு தூரம் இழுக்குது அப்படின்னு நம்ம கலோக்கியலா சொல்லுவோம். சரியா? மேக்னெட்டிக் ஃபீல்ட் இஸ் த ரீஜன் அரவுண்ட் த மேக்னெட் வேர் இட்ஸ் மேக்னெட்டிக் இன்ஃப்ளூயன்ஸ் இஸ் ஃபெல்ட். இதுதான் வந்து மேக்னெட்டிக் ஃபீல்டோட டெஃபினிஷன். ஓகே, மேக்னெட்டிக் ஃபீல்டோட டெஃபினிஷன். இது how it is denoted. It is denoted by the letter B. இது B என்னும் குறியீட்டால் குறிக்கப்படுகிறது. Next, one more experiment. இது நான் சொல்லிடுறேன், சொல்லிட்டு அதுக்கப்புறம் I got a compass and we will put the magnet, same magnet nearer to me. Okay, now you see, காந்த புலத்தில் ஒரு திசை காட்டியை வைப்பதன் மூலம் காந்தத்தை சுற்றியுள்ள காந்த புலத்தின் திசையை அறியலாம். The magnetic field is denoted by the letter B. The direction of the magnetic field around a magnet can be found by placing a compass in the magnetic field. Okay, now you see. Now you see, just listen. You are able to see the compass. See, just I will adjust in the north-south position. Okay, north-south position I have adjusted. This is the north-south position. It is the north-south position. Just you listen. Okay, now what I am doing, I am bringing the magnet nearer to it. Now I am bringing now what is happening, the magnet is getting deflected, so it is now tilted. It is now tilted. Now it is not northwest. Now it is not, you will be noticing it is not northwest, it is some other direction, northwest and southeast. So this direction is the magnetic field around the magnet. This direction is the magnetic field around the magnet. So this is the small experiment which I have demonstrated. Okay, you are able to see. Now I have removed. Now I have removed it. Now you see. See, the magnet is again northwest, because the magnet is very nearer to me. That is why the deflection is still noted. So now I have taken the magnet away. Just I have placed it away. Now you see it is come to northwest. Now I am just bringing the magnet inside. You can you will be able to see the deflection. So that is the direction of the northwest and southeast. Earlier, this is the field. This is the direction of the magnetic field. Okay, this is the small experiment which I wanted to show you. Okay, again I will tell you, this is denoted by the letter B. The magnetic field is denoted by the letter B. The direction of the magnetic field around a magnet can be found by placing a compass in the magnetic field. That is what which we have done. Okay, this higher in your higher standards, you will be doing some experiments called tan A and tan B position. In that, it will be done like that. It will be a very interesting experiment in physics. It's a very easy experiment also. So when you study 12th standard, remember this, how we are finding out the magnetic field. There also you will be finding out the magnetic field of the given magnet. Okay, like that only that experiment will be there. That will be one instrument will be there. In that, one compass will be in the center, and first you will be placing the magnet horizontally, then you will be placing the magnet vertically. Like that the experiment will go. This is just for your information, just for your keep your interest alive. I just told this. That will be a very interesting experiment which you will really enjoy. when you study your 11th or 12th standard. Okay, next, go to the next point. See, Gandha Visai Kodugal, that is, what is magnetic lines? Just I will tell it to you, then I will explain to you, then I will show the picture also. Gandha Pulathil வரையப்பட்ட ஒரு வளைவான கோடு. இதன் எந்த ஒரு புள்ளியிலும் வரையப்படும் தொடுகோடானது காந்த புலத்தின் திசையை காட்டுகிறது. இது எங்க it begins வட துருவத்தில் தொடங்கி தென் துருவத்தில் முடிவடைகிறது. Okay, just in the English I will tell you, then I will show the picture also, and with the picture also I will be able to explain to you. Magnetic field is the magnetic field line is defined as a curve drawn in the magnetic field in such a way that the tangent to the curve at any point gives the direction of the magnetic field. Start with north pole and ends with the south pole. Okay, now we will see. See, this is the direction of the magnetic field. That also I have shown to you. This is how this needle got deflected. That also I have shown to you. Now next we will see that magnetic lines. You see, now you see the magnetic lines. It starts from the north and ends with the south. This you have seen, and in the magnetic field in such a way that the tangent to the curve at any point gives the direction. So what is the tangent? Tamil sonna todugodu. This is the tangent. The tangent at any point shows the direction of the magnetic field. At any point, you touch here, this gives the direction. You touch here, this gives the direction. You touch here, here also this gives the direction. Here they have touched here, so it gives the direction of south. It gives the direction of some other direction, north, all northeast, northwest, southeast, like that. Any tangent if you put here, the தொடுகோடு இதுல போட்டீங்கன்னா அது அதனுடைய திசையை குறிக்கும். The tangent to the curve at any point gives the direction of the magnetic field. So this is the tangent. A is the tangent, B is the tangent, C is the tangent. This all shows the direction of the magnetic field. Start with north pole and ends with the south pole. Okay, we're able to understand this. It's an imaginary line. It's nothing line is put. It is like they're telling, government poverty line. Nothing, no line is put. Nobody, no line is put in any person's forehead. So it's a imaginary line. It's like that. It is also a imaginary line for your understanding of the magnetic field, and we have given this magnetic field lines. Okay, next. Same way, what I told you, ABC என்ற புள்ளிகளில் உள்ள தொடுகோடு காந்த புலத்தின் திசையை குறிக்கிறது. ஒவ்வொரு புள்ளியிலும் காந்த புலமானது தொடுகோட்டின் திசையிலேயே இருக்கும். You see, arrow mark indicates the direction of the magnetic field. This arrow mark indicates the direction of the magnetic field, and at any point is the tangent magnetic field at any point is tangential to the magnetic field, and at any point in this point also it will be a tangential. If you just put a line like this, it will be tangential to the magnetic field line. So if you put, this will show the direction. Here also, if you put a tangent, it will show the magnetic field direction. So the magnetic field direction. So this is how the magnetic field lines are. This is how the magnetic field lines are. Next, what we are going to see is magnetic flux. Next, what we are going to see is magnetic flux. See, just I will explain this, then I will show the things. ஒரு குறிப்பிட்ட பரப்பின் வழியாக கடந்து செல்லும் காந்த புல கோடுகளின் எண்ணிக்கை. இது பை என்னும் குறியீட்டால் குறிக்கப்படுகிறது. இதன் அலகு வெபர். WB is the symbol for that. This is defined as the number of magnetic field lines passing through a given area. It is denoted by pi. This spelling is PHI. There is one more pi which you know, pi r square. Pi r square or 2 pi r formula for, and that formula, that pi is also pi. This pi is different. This spelling I have given PHI. Its unit is Weber. This is defined as the number of magnetic field lines passing through a given area. It is denoted by the symbol pi. Okay, next. Then magnetic flux density, அதாவது காந்த விசை கோடுகளின் எண்ணிக்கை. அதாவது காந்த விசை கோடுகளுக்கு செங்குத்தாக அமைந்த ஓரலகு பரப்பை கடந்து செல்லும் காந்த விசை கோடுகளின் எண்ணிக்கை. அதுதான் மேக்னெட்டிக் ஃப்ளக்ஸ் டென்சிட்டி, காந்த புலத்தின் அடர்த்தி. காந்த புலத்தின் அடர்த்தி அப்படின்னு இங்கிலீஷ் சொல்லுவாங்க. The number of magnetic field line crossing through unit area kept normal to the direction of field lines is called magnetic flux density. Its unit is Weber per meter square. Its unit is Weber per meter square. That picture also I'll just share with you. Sorry. Now you can see the flux density. See, this is the flux density. See the lines which are going, which are kept normal to the direction of the field. See, this is called the normal to the magnetic flux density. Here, if you see less flux density, this is more flux density. This is more flux density. The number of magnetic field lines crossing unit area kept normal to the direction of the field lines. So this is the unit area. This is how it is crossing. This is less flux density. This is more flux. This is more flux density. That figure, exact figure also, I will just show it to you from the book. See, in the book, it is very clearly given. See, you see. This is the flux, magnetic flux. Magnetic flux is the number of magnetic field lines passing through a given area. This is the magnetic flux. This is the magnetic flux, and this is the magnetic flux density. Number of magnetic field lines crossing unit area kept normal to the direction of the field lines. This is the flux density, and this is the magnetic flux. Magnetic flux is the number of magnetic field lines passing through a given area. It is denoted by the symbol pi, and its unit is Weber per meter square. Okay, this is until this we'll see today. Remaining things we will see in the forthcoming classes. Until such time, thank you very much. வாழ்க பாரதம், வெல்க தமிழகம். Thank you very much.
நன்றி, வணக்கம்.